Welcome to all. Today I am demonstrating the design and testing Zene voltage regulator using multi-sim. Myself, Dr. Vishwanath Bia, Department of E&C, Rajiv Institute of Technology, Hassan. So what is a Zene voltage regulator? It is a specially designed diode to operate it in the reverse bias mode, and it is acting as a normal diode while in the forward bias condition. So, first, Zene diode understood that it is a special type of diode. Mainly, it is also similar to the PN junction diode, specially designed to operate it in the reverse bias mode. And it is acting as normal diode while forwarding bias. Means in both in the normal PN junction and the Zene voltage Zene diodes operated as it is same in forward bias condition, but especially in reverse bias conditions, it regulated the voltage levels, because in normal PN junction diode, if the reverse voltage is increases, sudden breakdown is occurred. Due to this breakdown, so the current will suddenly flow in the device, and the device may be breakdown. So to avoid this, we designing a special type of diode, that is Zene diode. It has a particular voltage that is known as breakdown voltage, at which the breakdowns while reverse bias, that is depending upon the Zene diode voltage, that breakdown is also varied. So selection of the Zene diode, also each Zene diode, there is unique voltage levels is there. So in this in our design, so we are using I1N753A. Its breakdown voltage is 6.2 volt, and that is the clamping voltage. Knee voltage is 6.2 volt. It's the voltage. So let us understood much more about the Zene voltage regulator. So here, in voltage regulators, there are two types of voltage regulation occur. One is the line regulation, and another one is the load regulation. So these Zene diode regulators help to maintain a constant output voltage despite the variation in the input voltage, that is line regulation, or load current, that means load regulations. So first of all, I understood what is the line regulations. The line regulation means ability of the regulator to maintain the constant output voltage despite changes in the input voltage. So we'll refer this in the input side. Okay. So line in Zene diodes, in ideal Zene diodes, we can consider the zero line regulations. Similarly, the load regulations we can measure in the output side. So load regulation is it the ability of the regulator to maintain a constant output voltage as the load current changes. As the load, even the load current changes, varying the resistance changes, the current, load current is maintain the constant output voltage. Maintain the constant output voltage. So now, so observe the Zene characteristics curve. I told that already during the forward bias conditions, both in PN junction diodes and Zene diodes are same characteristics are operant, but especially in reverse bias condition, there is a voltage is there, that is Zene breakdown voltage. After that Zene voltage, the characteristic curve, observe this, the current is breakdown, see the current is breakdown. So it varied from minimum Zene current, that is vary from minimum to maximum. The current is constant, that is constant Zene voltage you can see in the characteristics curves during the reverse bias conditions. Let's say this is the circuit I'm used for demonstration purpose. So in the circuits, 12 volt DC source voltage we are using, and the resistors R1 and R2. So it acts as a voltage divider, circuit. So understood that the Zene diode The reference voltage is 6.2. So up to 6.2, this it acts as an open circuits. Um, then after this, it allow the voltage levels. So the expected output voltage is 9 volts because the R1 and R2 is 1 kilo ohm and R2 is 3 kilo ohms. So by applying the voltage divider voltage, the output voltage expected output is 9 volt. So we can see in the demonstration the results. So I will select it uh, go to the multi-sim. Yes. So this is the circuits. Circuit I am used for demonstration purpose of the Zene diode. So 1N7534. So first I will change that. Once again, the implementation of the circuits, go to the place the components. So selecting the components, so DC voltage, okay, DC voltage and places, that is 12 volt is there. And similarly, register R1 and R2, the register R1 is 1 kilo and R2 3 kilo ohm. And for selection of the diodes, go to Zene diode. So go to the diodes in the database, Zene diode. So here you type this B 1N, sorry, 1N, 1N B4. Okay, I go for this circuit. Okay, 1N75. Yes, 75. All these are various Zener diodes with the operating voltage 753A. I have selected. This is 753A. Okay, selected. Okay, I already constructed the circuit. So just I showing the regulated voltage. So the input voltage I am choosing to 12 volt. More than always selected the above the Zener voltage. So this voltage always you selected. Okay, above the you can change 10 volt also. So just you run this. So transient is the before transient I show that in the probes, okay, negative 7. See, so here I'm using voltmeter, output voltmeter input, and also if you want to measuring the current, you can use the ammeters. Okay, so here there, okay, probes are there here. So now the run this. Just observe this. The voltage, DC voltage is how much? 10 volt. And maximum allowable voltage, you observe this is 6.13 voltage. Our Zener voltage cutoff, new voltage is how much? 6.2. Okay, 6.26. Okay, so current is this much for maximum. And what happen if the voltage is lower level? Okay, if I'm going 4 volt, so just I stop this 4 volt, then run this one. See, so what is the output voltage? 3 volt. Because it's divided this 4 volt is dividing 3 kilo ohm and 1 kilo ohm, and the voltage, applying the voltage divider by circuit, we got the voltage level is 3 volt. So so the 3 volt should have been clamped by Zener diode, but it is not able to switch on by this Zener. So it is output voltage. It's, this Zener diode is act as an open circuits. Okay, turn off the Zener diodes in this voltage because I am selecting the lower voltage of the Zener voltage. So just I will increasing 12 volt. Okay, once again 12 volt, and I is removing this Zener. So for verifying the, okay, 1 second, we'll stop this one running. Okay. Okay, so now I run this. What is the expected voltage? 9 voltage, because R1 is 1 kilo ohm, R2 is 3 kilo ohm. I obtain the voltage. So here in this output point, 9 volt is the DC voltage, and connected. I hope you all of you understood. Okay. See, the output voltage is 6.15. Okay, so we can this way we can verify the voltage regulations in using Zene voltage. So just I will show this in the transient analysis also, the output. So go to uh, simulated analysis and simulation. Otherwise we can select it directly in this window. Okay, there is a shortcut is there. So analysis, transient, go to select transient. Okay, save and run. So observe the waveform. So the maximum DC voltage 12 volt, and the output voltage blue color indicated what output voltage. Input voltage is indicated green color, probe 1, probe 2 output voltage, and current is zeros. So limited the. So these are the transient analysis output of the Zene voltage for DC voltage 12. So I hope you all of you understood how to regulate the uh, voltage by using Zene diode. Thank you.